and Happy New Year! First video of the year, and today I want to bring you two really cool launches from last re:Invent. We are going to talk about Bedrock Agents and Knowledge Base. You might think that these are not very serverlessy, and I hope that by the end of this video you are proven wrongly. But I think these launches are really great for developers. If you're a developer and you want to get into AI, you will really love agents and knowledge bases. So in this video, we are learning what are these two launches, what they mean from the perspective of a developer, and we are going to get to build our first agent. So let's get started. Bedrock Agents has been around for a while, so they were announced in preview in the middle of the year, but in re:Invent they were made generally available so everybody can play with them and try them. So what is an agent? If you never heard about agents in the AI context or in the generative AI world, basically the idea is that agents can manage and perform tasks by making API calls to different backends. They extend the foundational models by understanding the user request, break down complex tasks into multiple steps, carry on the conversation with the user, collect information that they need to perform the task, and then fulfill the request that the user wants. It's like a chatbot that we have been using for many years, very maybe rudimentary in the past, where you are going to your airline, WhatsApp or Facebook or Instagram, and you start chatting, hey, I have a problem with this, with my reservation, and then the bot will say, which reservation? And then you put the reservation number, and then it will ask you to follow some steps in order to help you to solve the problem. But the idea here is that the agents can understand better natural language, and also from the backend side, it's that you don't need to program so much in the backend. So I started this channel like 6 years ago, and one of my first series was to work with Amazon Lex. Amazon Lex was this chatbot kind of generator where you could use Lambda to make this user request, and then you have to program all the specific intents and all the API connections between Lex and Lambda. And also when you wanted to have these prompts, you have to be very specific of what you ask. So everything was very programmatic. With agents, it's like the next level of that. You as a developer do less, and the agent works way better. So let's see that in a demo in a moment. But agents in Bedrock allows you to automate a lot of tasks. So that's the idea stays the same. So you can do claim processing, bookings, shop, whatever you can do with a chatbot and more. So you can ask about this agent how much a flight will cost in Christmas from Montevideo to Helsinki, and the bot will get you an answer. And if it doesn't have, for example, if it needs a return date, it will ask you, is it a return flight or one way or whatever. How agents work. For this to work, you need to tell the agent what foundational model to use. So that's the first step. You can decide from all the foundational models that are available in Bedrock. Then you need to provide the basic instructions of what your agent should do. Book a flight or check reservations. Then you need to give access to some extra data to perform the task. The foundational models are trained on the internet, but not in your own corporate data. So if you want your model to be able to access, your customer database or your reservations database, you need to provide that access. And then finally, you need to specify what are the actions that they can do. So if they want to book a flight, you need to connect that agent to the booking flight API, and basically then you are done. After the agent is configured, then it will do all the prompt engineering and orchestration of the requested task. So this is very mind-blowing, and for me, it was not what I expected. I never worked with agents before. So when I started working with this, it was like, what? It's doing all the orchestration for me, and it does. And it helps you to build the prompts and translate all the prompts into API calls to perform those tasks, and then it converts the API responses into something that is friendly for the users. And we will see this in the demo in a second. So How this works: when a request comes into the agent, will use the foundational model to generate a sequence of steps. So that's something that the agent will do. It will orchestrate all the steps that they need to do. Gather all the information needed. For example, if you want to book a flight, it will ask you to where, what kind of flight, direct, over, or if it's one way, return, whatever it needs, date. And then it will get all the APIs that it has available in order to work. And then it will know when to call them and with what parameters. Then, when it has all the information gathered, it will execute the plan and call all the APIs with all the information that it collected. And then it will return the response to the user in the chat. So you will see at the end of this demo how does Bedrock all the heavy lifting for you while we build our agent. But first, let's chat a little bit about another important launch that we have this reInvent, and it's very important as building an agent that is the knowledge base. And you might be wondering what knowledge bases are. They also have been around in preview for some months, but they were made available in the conference. A knowledge base is basically a way to connect foundational models in Bedrock to your company data using Retrieval Augmented Generation, or RAG. So basically, these knowledge bases will do all the RAG processes for you. So when a model needs to access specific information from your organization to generate very accurate and context-aware responses without the need to retrain the model as well, because we don't want to retrain these very expensive foundational models, then they can fetch this information from a knowledge base. And the knowledge base basically helps the model as well, because it will provide like the source attribution from where it got the data. So this will help to improve the transparency of your model and minimize the hallucinations of your model. So then you know that whatever the model is returning has a fact behind it and it's coming from these references. The cool thing of knowledge bases in Bedrock is that it gives you a fully managed RAG experience. In the demo that is coming next, you will see how simple it is to do that, and basically just need to put data in S3 or in somewhere, point it, the location to your data. Then you can select the embedded models to convert that data into vector embeddings, that those will be the ones used by the foundational models to figure out what will happen. And then Bedrock will create the vector store and store all that data in there. So if you never heard what is a vector embedding, is basically a way of storing text data in a numerical representation within your documents. The idea is to capture this semantic or contextual meaning of data. So it's a cat, a feline, tiger, lion, they all might be grouped together like you see in the screen here. In this graph that you see in the screen, you can see that there is different groups, and you can see, for example, the light blue is like kitchen, vanity, sink, bathroom, toilet, bathroom. So these are, watery things. Then you have the purple one, charger, battery, tool, saw, some tools, and all these things are grouped together. So when the vector database, vector store is looking for something, it will find things around this context and this semantic, so it will be easier. So now let's go to the demo, because I think you have all the knowledge that you need in order to move on. In this demo, we are going to build the simplest agent in the planet, because I want to do it fast and I want to show you a little bit of the magic. But let me know if you want to build more complex things, or if you want to do it as infrastructure as code. I will be more than happy to do it. But this bot, what it does is a simple weather chatbot, in where you ask the weather in some particular city, and the bot returns the weather in some kind of friendly format. This agent uses a knowledge base where we are going to store all the latitudes and longitudes of all cities in the world. And then it has a Lambda function to perform the fetching of the weather of that particular city. So let's go to the console and create the knowledge base first. I'll go here to my AWS account and go to Bedrock. Just remember to be in a region where Bedrock is enabled. And here you can create a new knowledge base. I already have one, and I will use this one because it takes a while to load, but let's fake it a little bit. and create it from scratch. So you can give here a name, a description. It will create the roles for you. So that's nice. You can tag it. So here you can define where your data is. So I will point it to exactly the same place as I have already uploaded my data. We'll look at that in a second. Then here you can choose the embeddings modules. There is only one available in my account, the Titan Embeddings G1. And then it will create a new store that's recommended that makes an open search serverless vector store. And then you press next, you review everything, and you create the knowledge base. And this, what it does, it creates the knowledge base for you. I have it here because it takes a while to make that open search vector store. And here we have it, the latitude, longitude, cities, world vector space. And it has some description and the role that it was created automatically. Here is the file that I have. And basically here we can test the knowledge. So we can select a model to work with. Let's pick this one. And let's say, give me the lat and long for Montevideo. See if it works. So good. What is the lat and long for Helsinki? Good. So here we can click and it will show us the raw data. So if we open the S3 file, it's a CSV file where we have basically list of cities with latitudes and longitudes. It's just so simple. So now we have our knowledge base. And in order to create the knowledge base with that list of longitude and latitude, I took it from this page. I can show it to you, called Simple Maps. I will leave you the link in the description box, where you can download for free a list of cities with the latitude and longitude. So I use that one. So it looks something like this. And this is very useful for my particular demo. And this is what I uploaded. When you download this, you get a CVS file, and this is what I uploaded to S3. So if you want to try this demo, get the link from here. Now that we have a knowledge base in place, we need to code the Lambda function. The Lambda function will be the one calling the weather third-party service that I'm using. In this case, I'm using Open Weather Map that offers a free tier to get the weather for a particular city. So basically, this is the site, Open Weather Map. I will leave you the link in the description box so you can register if you want and try it out. But it's a very simple API that you can access and do whatever you want to do. It has some limitations if it's in the free tier, but it works very well. The thing with the weather API that it takes as input parameters, not the name of the city itself, but the latitude and longitude of that city. That's why we have to have that knowledge base with this list, and the agent will need to figure that out. So that's the magic part. There is no integration in our code. So now you might be wondering how all these things get together. Let's see. So we have the user making a request to the agent, and the agent will be using the foundational model to communicate. Then we'll have an open API definition for our function where we are going to specify all the input parameters and what each of the APIs do in natural language. And in this way, then the agent will know when to call this function. So now we can go to the code and see this in action. So the function, I already have deployed it and everything because I don't want to waste time, but I can show you the code and you can also get the code from GitHub. So the first bit is the template YAML. So this is built with some. Here we have our function. It's a normal function with some code, node 20, very little memory. And then the other important thing is this one. We need to give permissions to Bedrock Agent to access the function. So we need to give this kind of resource policy. So the function itself, we have the code here, index.js. It doesn't do much than calling the open API. But I have to say that I think the most important critical part of documentation that you need to save from this video is the documentation from the input and outputs that the Lambda function will give when it's connected to Bedrock Agent and needs to return to the Bedrock Agent in order to work. So this is a Lambda input event for Bedrock Agent, and basically this is the event object that the Lambda function will have. And basically from here you need to dig out all the information that you need in order to work with this agent. And then this is the response that Lambda needs to give to the agent, and it needs to give in this particular format in order for the agent to know what to do. So I will leave this link as well in the description box so you can bookmark it if you're working with agents. So now we are getting this event object with all that things that I show you. I'm going to get the API path from that event, and here we could have multiple APIs in the same function. So we could have multiple functions, or we could have multiple APIs in the same handler. In my case, I only have one, so I have the weather one. And as I told you, this weather API for calling the open weather takes the latitude and longitude. So we are just grabbing those from the event object. Then I'm calling the get weather, and basically that is calling the open weather API with the right parameters and an API key. And then I'm just returning this data back. I'm returning this data, and then I'm building the response in the format that Bedrock agent needs. So this is a fluff of just building things. So basically my business logic is that, and it's calling an external HTTP thing. But so with this in place, the other important bit that I want to show you is the open API definition. And this one I think is quite hard to write. There is the whole open API specification is open there. And the good thing is that the agent will tell you when something is missing and when something is required. So the first thing we need to do is to have an info. Then we have the path for the different APIs. I already said that we only have one. And in this case, it's a get weather. And here we have the description. And this is very important because the agent will read this. Get the weather for specific latitude, longitude to represent a city. Then we have the parameters. These are the input parameters. In our case, it's latitude and longitude. And here we need this description in place in order for the agent to know. And then you need to have the schema and things like that. And then the responses, again, the weather description for a given city. And then you pass what is the type. In this case, it's a JSON that I'm returning back. So now we deploy the function and we have the knowledge base. The next thing we need to do is to upload the open API definitions JSON that I show you to S3, and then we will tell the agent where that is. So that's something I already have done. So now we have everything. So let's go to create the agent. So let's go back to Amazon Bedrock, and in here, let's do agents. You can see that I have an agent already there ready, but we can create a new one. So let's call it here agent to weather. You can give a description, agent that gives the weather for a city. And then we can tell them if the agent can ask for more information or not. So I will say yes. I will tell them to create the permissions for me because I don't want to do that. And then the idle sessions, that's good. The timeout, 30 minutes. And it could be even shorter, but we don't care about that. Then we need to select the model. And in this case, we have Anthropic and then Claude 2. And here we can say something like this. You're an agent designed to help customers to get the weather details for a city. The customers will provide you with the city name, and you need to translate that into latitude and longitude. Return the results in a user-friendly manner. Good. The next thing we want to do is to do the action groups. And here we can define as many as we want. We can add, and these are the calls to Lambda. So we can do Lambda 1, weather. I get the weather. Here we can select our Lambda. Then I have deploy and the API schema that we uploaded already. Here it is. And then we do next. The next step is to select the knowledge base. This is the one that we created before. And we can also give instructions to the agent in order to what to do in that knowledge base. So I will give something like this: search for the latitude and longitude for the city that the user has given you in the prompt. I'm not an expert on this, but this works. And now we have the agent details that we can review, the model and the instructions, the action calls, the knowledge base, and then we can create the agent. This takes a little bit, and then we can test the agent when this is ready. So now we have our agent in place, and you can see that it popped up this test alias working draft. So if you go here, you can see your working draft. So now let's test this. And in order to test this, we have this test thing here that we can tell, give me the weather for Montevideo. And this takes a little while to think. And we can go to the Lambda function, to the logs, and we can see if that is getting invoked. Let's see. We should see that the function has run. Here we have it. We can see the event input, all this long thing with the parameters. We can see the call to the Open API, and we can see the response and everything. So if we go to the chatbot, it says the weather in Montevideo is conditions: thunderstorm with rain, moderate rain, temperature 20 degrees Celsius, feels 20 degrees, humidity, blah, blah, blah. One of my favorite things, and at least where I learned quite a lot from Bedrock, is when I click this show trace. And here you can really see how the agent reasoned. So this is a pre-processing state, and you can open it here, and you can see all these prompts that the model is doing and deciding. So you have not written any of these. You can override them, but it's just really cool to see the rationale and see here, based on the functions that are all these that are here. The input, give me the weather from Montevideo, appears to be a request for weather information from the city of Montevideo. To fulfill this request, the function calling agent will need to first use the get Amazon knowledge base search function to find the latitude and longitude for Montevideo. It will then pass those coordinates to the weather agent function to retrieve the actual weather function. Since the sequence of functions could possibly retrieve the requested information, I believe this input falls into category D, that is from the list of these things. Then the next step is the orchestration and knowledge base. So you can see here that what is going on. Let's see where the agent replies. Oh, this is all generated and orchestrated for you. So this is really cool. And you can see here is calling the knowledge base, and it's doing some searching and blah, blah, blah. Then it's trying to find that. Here is the user question: what is the latitude and longitude from Montevideo? Question is referring for a search result. And you can really see what is going on. So let's see if it gets the answer eventually, because it's passing so much information. I have received the latitude and longitude from Montevideo from the knowledge base. I will not call the weather. So this is part of the orchestration. And this should be calling the weather and making the response human readable. You can see all the steps, and if you have some pre-processing, you will be seeing it here. So now you have your agent, and what you can do is you can deploy it if you want. You can create an alias and deploy it, and then you can use it in your web applications. So that's the video for me today. It's a long video with a lot of information, but I would love to know if you want me to talk more about agents, how to build them, do more complex things, build this as infrastructure as code, because you can do it. If you want to see how to integrate this in a client application, let me know. We can build that together. I'm always happy to experiment on these things. And here you can find a playlist with all the announcements from re:Invent and this year. And you can find here a link about step functions and Bedrock. So if you want to orchestrate your generative AI in a more traditional way, go and check that one. I think this is a great way, step functions and Bedrock, for the asynchronous part of orchestrations. When you want to do generative AI in more asynchronous flows, these agents is really cool for the synchronous flow to talk to a human, a chatbot. So there are different use cases. And I see you in the next episode of FooBar. Ciao, ciao.